Okay, for this exercise, we're going to take a look at a sheet of music. I'm going to record these musical notes in a spreadsheet. Well, actually, I already did. And I found this little chart on the internet. What it does is it takes each musical note and it gives you the corresponding frequency that goes with that note. And so here's the frequencies that correspond with each of the musical notes that I'm interested in. And now I'm going to go collect some other information. All right, what I have here is a generator with an external input. And if I put a DC voltage into that input, it will change the frequency coming out of the generator. So, for instance, if I turn the voltage up here, I think you can probably hear that coming through the camera. It's changing the frequency. So basically what we want to do is take a look at the different notes and the frequencies and figure out what DC voltage we can apply to get that particular note. So for instance, this meter will monitor the DC voltage coming out of the power supply. This meter will monitor the frequency coming out of the signal generator. And our first target frequency is 130.81 hertz. So I'm not going to get this exactly right, but I'm going to try to get it kind of close. So 130.81 hertz. That's pretty close. So we're going to call that 2.70 or 2.7. Yeah, I'll be at this all day. Let's see, 130. 2.763 is about right. So, and I'm going to go through and collect the rest of the voltage data. Finding out the 261.63, and I'm going to call that 9.73 volts per hour. Okay, I'm going to clean up my spreadsheet a little bit because we're going to do something with this. And once I get all this laid out the way I like it, then I will record the voltage data that I just collected. Ta-da! All right, here's where it starts to get a little interesting. This is a programmable controller with an external power supply that I use for other stuff. Um, this right here is a digital to analog module, meaning that I can input a number and get out a corresponding voltage. Now, this particular one is a 12-bit module, so with a little bit of math, the next job is going to be to convert our voltages into an equivalent binary number. Okay, so the next step is we're going to want to convert this voltage into a digital number that we're going to put into that module. So first, let's figure out how many counts we have. Um, let's see, this is a 12-bit module. So to figure out the number of counts, we would say that's equal to 2 to the power of 12. Uh, yeah, except we're going to have to subtract 1 from that because we want to leave the headroom um, for the 0. We're using a whole number system here. So 4,095, that's good. Um, let's see, let's title these things so we know that they are. This is the count. And then we're going to want to know the maximum voltage, which for this particular module is 10 volts. So at 0, the count would be 0. At the maximum count of 495, it would be 10 volts. And then I think, let's see, we want to figure out the count per volt times the volt, and that would give us the count. So let's do count per volt, and that's going to be A12 divided by B12. I could just say 10, I guess. Oops, Let's put in an equal sign there. Details, details, and enter. Okay, so yeah, 4095 divided by 10. That's great, Doug. Okay, 409.5. So let's see, if we multiply that number times this, let's say that's equal to C2, and that's going to be times 409.5, and that's the count out of the module that will get us that note. So let's go ahead and do that for the rest of these guys. I know I'm going to have to round these because it's a binary counter. I know I could do that in the settings, but I'm awfully clumsy with these programs. I'll just do it on the fly. We're going to use something called a drum in the PLC, which is meant to emulate something like an old music box where you get these tabs that generate different notes. A quick look at the structure of this thing. We have these columns that are numbered 1 through 9. We can think of each column as being a particular note. So, for instance, one could be C, two could be D, three, and so on. And then what happens when we start this drum? It goes line by line. So in this case, it's saying that it's going to turn on this particular note. I reserved number 9 as a point that we'll use to turn the speaker on and off. That way we can get a separation between notes. So at any rate, this first note, which is, let's see, C, D, E, F, G, G will be on for 500 milliseconds as our base, so a half second, in other words. And then we'll turn on a gap for just 100 milliseconds, so we have that separation. And this will be going down through the first 6 notes, and I'm leaving it with the last space being turned off, so we have a gap before we move on to the next section. Kind of neat. You can just turn these different notes on and off. It's a real simple process inside the program here. And the other thing is each of these output numbers, we have a list down here. This is the output, the memory point location that's associated with each particular column. So C1, that's not to be confused with a musical note. That's just a memory point. So we're using memory points C1 through C9 to correspond with these output numbers inside the drum. Okay, so stepping outside of the drum and looking at the main program, here's the memory points that we just looked at, C1 through C9. And most of these are set up to do a math function. And basically, what it's doing is it's uh, taking, there's not really much math involved. It's just taking this number 1104, which is our integer that corresponds with the musical note C, and it's taking that number and it's loading it into a register called DF5. And DF5 is the input register for the analog output module. So we're basically just taking that number and loading it into the digital to analog converter. So here's our 8 musical notes, and C9, we'll be using that to turn on a physical output that will have activate or deactivate a relay to generate the space in between our notes. And yeah, that's about it. Oh, one last thing is I haven't finished setting this up yet, but these drums have a maximum of 16 steps, and we have more than 16 notes. So I'm actually cascading these drums in such a way that when one finishes, it activates the next one, and we just kind of daisy chain these things until we get all the notes that we need. We'll write the project to the PLC. And warning, two or more output instructions refer to the same address. Generally considered a big no-no, but I'd like to think I know what I'm doing. So we'll say okay. We'll take the PLC out of the run mode, finish loading the program. Transfer complete. And now we turn on the PLC and let's hear what we got. All right, here we go. Here's your birthday present. Happy birthday to you. Happy birthday to you. Happy birthday, dear Richard. Happy birthday to you. Happy birthday, big brother.